Ngalakin kadijan yung boja.
Welcome everybody to Lab 3, the last lab in Engineering Science 3016. Today, as in Lab 2, we're going to look at induction machines. However, this time we're going to focus on a single-phase induction machine. So this panel here we haven't used before in previous labs, but it just creates a variable AC voltage source. And here in the middle we have our familiar measurements of AC voltage on the top and AC current on the bottom. This panel simply allows us to create a capacitance, and note the little black knob on the bottom right here, which allows us to either connect the capacitance into the circuit or open circuit it from the rest of the induction machine. So we're using the same AC machine as what we used in the last two labs. However, importantly, the winding configuration is different here, so please check your lab manual to see what those differences are. And again, we're using the Prony brake to apply a variable load torque to the single-phase AC machine. At this point you can see that I have applied voltage to the stator windings. The machine has sped up, and now we can see what voltage we're applying to the stator windings and the resulting current that is flowing through those windings. You just saw me flick that little toggle switch that was on the capacitance panel, which has now removed the capacitors or removed the capacitive winding from the single phase induction machine, but we can hear that the machine is still spinning. So what I've done here is now try to start the machine again by applying stator voltage to it, but because that little black toggle switch is turned to the off position, we no longer have the capacitive start winding, therefore the machine doesn't start. You can see here that I'm adjusting the prony brake, so I'm slowly increasing the mechanical load torque that I'm applying to the machine, and we can see what effect that is having on the stator current. So at this point I've adjusted the prony brake to apply a small load of about 0.2 of a Newton meter. Then I note that I have approximately 135 volts that I'm applying to the stator winding. So what I'm going to do in the next sequence is slowly reduce the stator winding voltage and take measurements of the speed. So we can see there that there's a point beyond which, if I reduce the stator voltage beyond, then the motor stalls. And that's it for Lab 3, everybody. Good luck with your report.